In this session, we will be looking at a more sophisticated technique called the high-low method to estimate future costs. Here is data that Charlene's Computer Care has gathered over 15 months. They collected information about their total overhead costs and about the number of hours that they spent repairing computers. And we are going to use this information to try to come to a better understanding of costs within the relevant range. That is, we are only comfortable predicting costs within the range for which Charlene has gathered data. So the first thing that we would want to do is to graph this information, because we know that our cost volume profit analysis is based on a belief that the relationship between these two variables approximates a straight line. So here's a scatter graph that Charlene generated in Excel. When you look at it, do you see a relationship? Clearly, this data approximates a straight line. That means it is suitable for this type of analysis. Now, what we are interested in for the high-low method is the high point and the low point of Charlene's activity levels. The high point occurred in month 7 when she used 568 repair hours. The low point occurred in month 5 when she used 200 repair hours. We can now ignore all of the intermediate points because we believe that a straight line describes the relationship of all of these points. So we are going to focus our attention on the high point and the low point of Charlene's relevant range. And within that range, we are going to use the mathematics for a straight line to predict overhead costs for any level of activity within that range. So, looking back at our data, the high activity level was the month when she used 568 repair hours and she incurred $12,883 of overhead costs. The low activity level was the month when she used 200 repair hours and incurred a little over $9,000 of overhead costs. If you remember from algebra, the formula for a straight line is y equals a plus bx. Let's take a closer look at that formula. Y is what's called the dependent variable or the outcome variable. That means we believe that its value depends on whatever happens on the right-hand side of the equation. In this case, our dependent variable is total cost. So we are trying to use this equation to predict future total cost. A is what's called the y-intercept. That is the point where a straight line crosses the y-axis. In our methodology, that represents the amount of fixed cost, the amount of cost that would be there even if our activity level is 0. B is the slope of the line. That is how tilted the line is away from horizontal. If a line is perfectly horizontal, then we're talking about a totally fixed cost. So if the line has a bit of a slope, that means a portion of the costs are variable. So the slope of the line represents the variable cost per unit. X is the independent variable, or it's sometimes called a predictor variable. In other words, we believe that the value of Y depends on the value of X, the activity level. For Charlene's computer care, her activity level is measured by the number of repair hours. So what she's saying is that she thinks that the number of repair hours affects her total overhead cost. The formula for the slope of a straight line is the change in Y over the change in X. So let's figure out the slope of the cost line for Charlene's computers. The change in Y is the difference between the cost at the high point and the cost at the low point. The change in X is the difference between the number of repair hours at the high point and at the low point. When we crank that out, we get a number, 10.40. That means that Charlene predicts that her variable cost per repair hour is about $10.40. To find the y-intercept, we should choose either the high point or the low point. Then we are going to substitute the slope that we just computed into our equation and solve for A, which represents the y-intercept or the fixed cost. So here's our formula for a straight line. At the low point, our cost is a little over $9,000. We have 200 repair hours. If we choose the high point, then our overhead cost is almost $13,000 and we have 568 repair hours. It doesn't matter which point we choose. Either way, we are going to substitute these numbers into our equation. I chose the high point. So that means that Y, our total cost, is $12,883. A is the number that we're looking for. That represents the portion of the total cost that is fixed. The variable portion is going to be our slope of the line, $10.40 per repair hour, times the number of repair hours, which at the high point is 568. Now all we have to do is solve for A. We can multiply the variable cost per repair hour times the number of repair hours. That will give us our total variable cost. Then we can subtract the variable cost from the total cost, and that should give us the portion of the cost that is fixed. Now, we can put all of this information back into a general formula for predicting total cost at any level of activity within the relevant range. The formula is going to be total cost Y is equal to $6,976, which represents the fixed portion of the cost, plus the variable cost per unit, $10.40, times X, whatever our level of activity happens to be. So, for example, if Charlene expects that next month she'll be using 480 repair hours, we simply substitute that for X in our equation, crank out the math, and find that her best prediction of total cost would be just under $12,000. Let's put this methodology into use in a practice problem. We're given some information about a firm. Your first job is to determine the estimated variable overhead per machine hour for this firm. We know that the basic formula for the slope of a line is the difference in y divided by the difference in x. The difference in y is going to be the difference in cost between the high and the low points. The difference in x is the difference in our activity level between the high and low points. Then we can divide the difference in machine hours into the difference in cost, and that tells us that we estimate the variable cost per machine hour to be $37.50. Your next job is to determine the estimated fixed overhead for this firm. To answer this question, we need to look at the basic formula for a straight line. We know that at the high point, our total cost is $26,250, and our level of activity is 450 machine hours. We can plug that information into our formula, solve for A, and it turns out that our fixed cost is $9,375. We could do the same thing at the low point, and if we did, we would find that it gives us exactly the same answer, because these represent the end points of the same straight line. Your third job is to determine how much overhead would we predict if we expected to use 360 machine hours next period. To answer this question, we go back to our basic formula. We're trying to predict y, which represents the total cost, and we believe that that is equal to the fixed cost plus the variable cost per machine hour times the number of machine hours. Crank it out, and it tells us that we would predict $22,875 of total cost in the coming period.